pyramid, because we're not going to do any oblique ones. We're going to do all straight ones, okay? It's going to go to the center of your base, okay? So if this is badly drawn, but center of the base here would be the middle of the square, okay? Which means that from the center to the side here, the center to the front, the center to the other part, all those distances would all be the same, okay? Think of this point here as the midpoint of the entire base. Does that make sense?
So if it's the midpoint, if we said this length here was 12, from that height to the side is a measure of what? No, the whole length of the pyramid is 12. 6, right, half of that. You guys see that? Half of that. Because you guys are going to need to use.
It's hard to do perspective.
You guys will need to use Pythagorean theorem. I know, I didn't mean to say the PT, but yes, you still need that, right? You're going to need that if you're missing the slant height, because you're going to need that in the formula. If they give you the h, the height, you're going to need to use Pythagorean theorem, knowing that that height is bisecting that length. It's going to cut it in half. And Pythagorean theorem to find the slant.
It's like Ms. Thoreau was just saying, there's a front and new term here. It's called that slant height. The slant height is the height of the triangle of the side. It's the going down the side of it. If you wanted to ride on a sled, you'd probably want to sled down the side, not down the middle, because you would just die.
This is actually a little sled on the tippy point here. There you go.
Went down the middle. Which one looked a little bit less violent? Again. Never mind. So it's a new thing called a slant height. The slant height is down the face of the pyramid. Down the face of the pyramid. And what it does is it also bisects that triangle. So you get a bunch of different bisecting pieces because these triangles themselves will also become isosceles. Okay? So you get isosceles triangles. Sometimes they'll be equilateral. It'll be equilateral if it's a square base, but sometimes they might not be. They could be. It just depends on how it's drawn and how it's all put together. But you've got just a couple new parts here. Okay. Now the cone and the pyramid, they both have these things called slant heights. They both have bases. They both have vertical heights. The difference is between the two is that in a cone, what's the base going to always look like? It's a circle. Okay. Versus with these guys, you'll have square bases, triangular bases, pentagon bases, octagon bases, and so on and so on and so on. Or heptagon-based pyramid that's up there as well. Okay. There's all these different things that you can do with that. It just depends on what it is. So you have to understand a couple of parts. Formulas, again, they are super easy to work with. You get the formula, and I know it's on your formula sheet as well. The surface area of a pyramid is going to be big B plus half the perimeter of that base times the slant height. They use it didn't show up, it's kind of hard to put cursive here, so let me do this. The surface area of a pyramid is going to equal to big B plus 1/2 the perimeter of that base, slant height. And slant height is usually used as a cursive lowercase l. I know we've seen that as line, but they call it for slant height in this case. Okay.
Now, question. Yesterday, you guys did surface area prisms, right? How many bases did you have? 2. Why don't you have 2B here? Or not 2B? I'm nervous. How come we don't have? Yeah, right. The size I'll leave at the point, right? There's only one base. Good.
And that P, remember, it's the perimeter of the base. How do you find perimeter again? Add what? Size over what? Base.
So it would behoove you. It would behoove you when you're working on surface area because you have to find perimeter and the area of the base. My suggestion would be always to redraw that base with all your numbers in place. So if you redraw the shape of the base, if it's a rectangle, if it's a trapezoid, if it's a triangle, if it's a pentagon, redraw the base, and then you can easily then from there calculate, put your numbers in from the figure here, and then calculate perimeter and area, because you're going to need both of those in the formulas here to find surface area.
Like we said yesterday, I would make sure that you have this diagram on your formula sheet. Just because it is very useful, because guess what? Dun, dun, dun. Well, in theory you could, but you will actually use it, because remember, find the outside angle, you take 360 divided by the number of sides. These angles were bisected because of supplement. That's your applicable. I know we've done, I don't know, 73 or 74 of these problems maybe. 83, 84. Well, I know I've done, and you've done, so we've done rather well with those. That's big for me. I'm really happy right now. I just don't want to show off too much. So in this case here, oh, I forgot to draw a little perpendicular. In this one here, we have a square-based pyramid. And what we want to do is find the surface area of it. So when you have a square-based pyramid, first thing you want to do, just like we did yesterday, yeah, exactly, Josh. You want to write out your formula. So we have surface area, pyramid, big B, perimeter, 1/2 perimeter. Big B is a what?
What is the base? What is the shape?
Square. And how do you find the area for a square? Yeah, base times height. What I'm doing here is I'm trying to make this as foolproof as possible, because, oh, that's right, everything is on your formula sheets. If you understand what to look for, you know what to write down. So this is tough. Let's see if we can figure this out. 10 times 10. 200. Okay. Perimeter. When you find the perimeter of a square, how many sides do you have to add up? 10. So what's going to be 10 plus 10 plus 10 plus 10? Last thing we have to figure out then is our slant height. When you have your slant height here, you'll notice that it gave you the vertical height, and you know the distance from the side to the edge. So what you have then is a triangle, happens to be a right triangle. Like that for right now. Which means you have to use, so 5 squared plus 12 squared equals something squared. And the square root of that is? Very good. You use Pythagorean theorem to figure out your slant height in this case. Okay. A lot of times that's basically the only extra step that you need to do for most of these types of problems. Find a slant height, maybe find a vertical height, along those lines. They're really, cones and pyramids are pretty quick. Pretty quick. No, but I think we have to put the form from all in the formula part now. What do you mean? Add? Yeah. That would be perimeter then. Your slant height is just that diagonal part. That's all it is. That's all that is. Okay. So that's 13. So now you've got your big B, your perimeter, and your slant height. Now you just put it all together at once. 100 plus half of 40 times 13. Very good. 360 something squared. Remember to have throw our units in because it's surface area. Okay. That's why we break it apart into each individual pieces, so you know what parts go where. So when you substitute in, you know what numbers go where. That's why we set it up. Okay. 360 something squared. Okay. Very, very, very straightforward. Nothing too crazy. Question about that at all? Now, a second ago, you guys told me the difference between a pyramid and a cone was the base of a cone. So pyramid versus cone. The pyramids were big B plus 1/2 perimeter slant height. Well, what's the shape of every single cone? It's a circle. So big B for a cone will always be a circle. What's the formula for the area of a circle? That would be circumference here. So look at your formula sheet. The area of a circle is, again, that's circumference. Look at your formula sheet for the area of a circle. Pi r squared. Thank you.
Don't get, you guys, if you don't have it memorized, I'm a big proponent of memorizing, but that's crazy. I would say, yeah, use your formula. Just don't guess on this. Pi r squared is the area of a circle, that's the base of the cone.
And now, how do you find the perimeter? What is the perimeter of a circle called?
The
Circumference. And what do you do? How do you find circumference? There's no squared in circumference. Read your formula sheet. It's on there. There's no squaring in circumference. Circumference is perimeter. Perimeter doesn't square. Perimeter is just adding stuff together. Perimeter is a singular dimension. Okay? So we add to it half of 2 pi r. And again, we have a slant height. Well, what's half of 2?
1.
So they don't write it that way. They write it as this. Pi r squared plus pi r l. That's how you find the surface area of the cone. That's what it meant on your formula sheet of how all that goes. So on here, I know that cursive L kind of looks like a little bit like an E. It's the best we can do with the typesetting on this. It looks like almost looks like an E. It's a weird little L. But it just means, remember, that stands for slant height. Pi r squared times pi r. Yeah, it could be. I see what you're saying there. All right, but remember, it's the stuff here is here, guys. So that's where you get the difference between the two. It's the exact same formula, but since we're always dealing with cones, or since cones always have circles for stuff, that's why it looks like that. Okay. Does that make sense? All right. Let's look at an example. Finesse yourself back over there. So in this one here, we've got a cone. Obvious, because it looks like a cone. Which means you have a circle, and you've got the cone part. What part's missing according to the diagram? Slant height. Gee, I wonder what you're going to have to do to figure out the slant height of a cone.
Definitely not going to be the PT word.
I bet you're wrong. Remember, what happens here with cones, if you think about it, the cone still has a triangle built into it. The cone can still take the triangle. If you've ever taken, I think we can draw it.
So I make cones at the ice cream shop. When I make cones at the ice cream shop, you guys have ever made waffles before from those waffle makers? It's basically a waffle maker with a really thin grate, and I just pour the waffle mix on there, and I bake it just like a waffle. When I take it off with a spatula, it's a circle, and I put it on my little, it's called a cone forming tool, and I
The cone roller?
I roll it when it's hot, and it cools, and it makes a nice little cone shape.
My keys are making a circle, right? If I keep my arm, I'm trying here, right? If you look, it's not hitting head. If I do this, if this is the tip of the cone going up to the edge, does that make a triangle?
Yeah.
I'm trying to think of a way to show you guys. visualize what that does. But that's really all it is. Again, we're not talking about what I mean by this term called oblique cone. It's a non-right cone. It's a cone that kind of fell over. It's a lopsided cone. Yeah, they're still edible. Yeah, it's a 5-second rule thing. So how do you figure out the hypotenuse in this case?
Well, you do 6 squared plus 8 squared.
What's 6 squared plus 8 squared?
100.
What's the square root of 100?
10.
So what's your slant height?
10.
10. So we have our radius is 6, our slant height is 10, which means with cones, you can just go right to the formula.
Yeah.
Pi r squared plus pi r L. So you've got 6 squared times pi plus. Yes. But be careful when a lot of you guys were messing up on that one quiz a couple of days ago. You were squaring pi, not the radius. Yeah, lots. Yep. So let's see, 6 squared is how much? 6 times 10 is? 36 and 60 is how much? Answer is 96 pi something squared. Remember, when you're putting these things together, you're treating pi as it were a regular old variable. You're just combining like terms. This hasn't changed since we've been dealing with it forever. Okay? Honestly, the only weird thing that's going to happen with this stuff, guys, is when we start talking about what are called composites. Yeah, I'm going to do a couple of them today. So what I mean is we're going to find surface area of that. And if you look at that, that's what on top of a what? If I do it this way, yes. You're not wrong, though. It's a cylinder and a cone. Now, if you think about what surface area is nothing more than how much you need to wrap everything up. Okay? That's what surface area is. How much wrapping paper would you need to cover something? Versus volume, which we'll get to next week, how much crap can you fit in something? For lack of better terms. That was good. I like that one. That was good. That was very good. Air 5 for that one. Nice job. Anyway, so if I was going to take a cylinder, pardon my super awesome drawing. If I take a cylinder and I put a cone on top of it, it's more than that. It's really good. Let's see if I can group this real quick. All right. So if I take a cylinder and I put a cone on top of it, if I start thinking about the formulas, if you think about formulas, formula for the cylinder was what? 2 pi r squared plus 2 pi r h for that, and then the cone would have been pi r squared plus pi r l. That's what it would be to add those two together, correct? Now, if you think about it, yes, Josh. You can, but before I get to that, if you think about with a cylinder and a cone together, is there anything on this object that you can't wrap with paper? What do you mean?
No, he's still gonna wrap the.
I'd still wrap the bottom here, but what won't be wrapped with paper?
There are two parts that are touching each other from the two shapes.
The overlap. Okay? When you take a cone and put it on top of a cylinder, what's overlapped? Two circles. So what can't you wrap with paper? Two circles. So in here, where do you see two circles that you would not count? So the idea here is if you have a cylinder and a cone, you have your formulas for both, but then you have to realize that you can't double count something. Right? You wouldn't double count something. It's kind of the idea where we did some with shaded region. On the area of shaded region, you would back stuff out that was non-shaded. Well, this is no longer shaded because it's covered up. Does that make sense?
Yeah.
It's the same idea when you have pyramids and prisms. Depending upon what shapes they are, sometimes you just have to back out, usually, 2 bases. And that's what they would look like. More often than not, you would have a, obviously with a cylinder on top of a cone. Well, actually, let's just do an example. I think I have one up maybe here somewhere. I look at this. Oops, sorry, didn't mean for that to be that loud. If I look at this, that's all that is. It's a cylinder and a cone, isn't it? It's a cylinder and a cone. Do you have enough information to find the surface area of the cylinder? Yeah, we have the vertical height, distance between the bases. We have the radius. Do we have enough information to figure out the surface area of the cone?
Yeah.
Yeah, we have the slant height. The slant height's given in this case. Do you need to know the vertical height of a cone to find its surface area? Nope, because it's not in the formula. So if you look at what you have here, as you start putting it together, you've got your surface area of a cylinder plus the surface area of a cone. And then, since they're all the same size, because they kind of have to be, what do you have to subtract? How many? Then you just have to subtract out 2 circles. All right? What I'm doing here is I'm starting by writing down the 2 separate formulas. And then what do you have to back out in the long run? What's covered up? 2 circles. And I'm showing, yeah, I'm talking as I go through, because now I know what is the formula for cylinder. Well, cylinder is 2 pi r squared plus 2 pi r h. Cone is pi r squared plus pi r l. And then I know that I'd have to back out 2 pi r squared. And that's what I'm getting at. What did you have to back out that was overlapped for 2 circles? By saying what you have to back out ahead of time, you'll remember to take it out later. So now, like you were just saying, when you just cross it out, yep, because these 2 are the same, and now I just go through the rest of it and fill in the blanks. And again, worst case scenario here, ladies and gentlemen, is that you might not be given a slant height, you might be given the vertical height of the cone, you have to find the slant height, but how do you do that? Pythagorean theorem. Again, you might be given a diameter. Oh no, how do you find the radius if you have a diameter, all right? Yeah, it's not that it's any, this is going to be
Would they ever be given the height and the slant height and they have to find the diameter to look at the radius? Would they ever get like, I guess
yeah,
find
you
the
can do that.
radius?
Yeah, you can find the radius that way. Yeah, it's in, you guys understand what Mr. Roy was saying there?
Yeah.
If you have a cone, if you have a cone, you might be given the vertical height at like 16, and the slant height would be 27. You'd have to find the radius using Pythagorean theorem. Because remember, with any of these types of formulas and stuff, even with anything with Pythagorean theorem, if you've got 2 out of the 3, you can find the third. Okay, and that's kind of what this looks like. So from here, this is really, it's nothing more than just writing values and pressing buttons. So if we try this, what's our radius on this one? 2. What was the vertical height? Vertical height. 2, so it's 2 times 5 times 2 times pi plus 2 squared pi plus 2 times 7 times pi. And once again, you can type all of that directly into your calculator with pi buttons, and it'll give you an answer. But honestly, it's probably easier not to use your calculator, because what's 2 times 5? Times 2. 20 pi, 4 pi, 40. Once again, 4 plus 14 plus 20, your answer. 38 pi inches squared. It's the idea that you look at the fact that the formulas themselves are super easy to work with. You just gotta do that. What would be different if I took a cylinder and I put a cone inside it? How'd you find the surface area of that? Oh, I'm thinking of the whole. Never mind. We'll do this one with volume. This one gets messy with surface area because then you'd have to subtract out, because this would be open. So you'd have to subtract out 2 circles and then wedge it. Yeah, never mind. We'll do this one with volume because it's really easy. See if I have one with. Let's try one.